computer. I think I've actually recorded the first bit by accident. Okay, yep, we're recording. So, hey everyone, welcome to our second remote code harbor. Hey. I just realised I shouldn't have muted you all because that was really weird hearing just my voice. But yeah, so thanks everyone for logging in. It went really well last month, so yes, I think tonight's been really awesome. So yeah, obviously we've been nattering away for like 10 minutes, so we'll just go straight in. And so we've got 6-2's Aaron Taylor is back after a year to tell us about returning the carriage and feeding the line. So away you go.
Excellent. All right, I'm gonna share that. All right, can everyone see my screen? Yep. Oh, okay. Oh yeah. Nope. Oh, wait a sec. I need to actually click the share button. That would be quite useful. Right. Can everyone still see my screen? Yes. All right. And you can't see my presenter notes in front of it, can you? Oh, crap. Sorry. All right. Yes. Okay. So you can only see the presentation. Is that correct?
And your
no, I can see that.
You can see my notes.
Yeah, I can see what
Really?
that. There's like a pop-up box on top of it for some reason.
All right. Is that gone now?
Nope.
All right. Let me try this again real quick. And
Are you not dual screening?
yeah, I am dual screening.
It's popping up. Sorry, guys.
All right. Well, it's just that because I'm going to be like looking up here, and I just thought if you are looking at me and not at the screen, then you'll see me looking off to the side. Anyway, all right. I'm just gonna go from here. Okay. Yes. Hello. Welcome, everyone. My name is Aaron Taylor. This little talk is called "Return the Carriage, Feed the Line," or a brief, wholly unnecessary but quite interesting history of a couple of overlooked technological quirks and the decisions that made them. Yes, I rule at titles. That is like my superpower. So, here we go. As with all good stories, and I'll tell you two stories this evening. The first one doesn't start with someone you know, but it in fact starts with someone that you don't. This guy. Anyone know him? No, didn't think so. His name is Gary Kildall. Gary Kildall is the author of the seminal operating system. It's one that we all know and love, and it's called CP/M or CPM. Nope, no one knows it. Yep, I didn't either until I started writing this talk. So picture this. It's late 1973, and Gary has a decision to make. And it's a decision that will go on to have massive ramifications for computer science and all those who practice it. It's a decision that we still feel the effects of today, and one that I personally feel that it's cost. I think it's cost the IT and computing industry billions over the years. I think it's cost us time, frustration, hair pulling, extra code having to be written, and all sorts of things. But you see, back in 1973, Gary didn't know that this was going to be the case because Gary was working on problems of his own. He was working on the future, and he also needed to support the present and also, quite importantly, support the past. And the past came in the shape of this thing. This is the mighty Teletype Model 33. This beauty in beige was one of the first user interfaces. An operator would stand at this Teletype machine and they were typing commands which would then be sent to the mainframe computer, the responses of which would then be printed out on, can you see my mouse cursor? Yeah, this roll of paper here. just at the top there, the commands would be printed out on that, and you'll see the response from the mainframe computer. I mean, this baby was capable of printing a staggering 100 words a minute. That's almost 85 baud. Yeah, big stuff. There are a couple of interesting keys on the Model 33, and this is a close-up of a keyboard, not the Model 33, but a similar teletype machine. And I'll just draw your attention to these two interesting keys. So the one top right here, that's the carriage return key, and the one bottom to the left is the line feed key. So hoping these are starting to sound a little bit familiar to the programmers out there. Now, remember, this is 1973, and even back then, carriage return and line feed, they were still pretty archaic. They're actually direct imports from when typewriters were the height of information technology. And for all those that are curious as to what a typewriter actually looks like, here's a handy diagram that I found on the internet. So in the middle is the typewriter. To the left is the carriage return line feed lever. This is an Underwood 5, wholly unremarkable typewriter, which is why the company no longer exists. But as we see, we, with an uppy-downy motion, are able to feed the line. So move the print head where the keys will strike to a new line. And with a lefty-righty action, we're able to do the carriage return. So the big thing here that the paper wrapped around is called the carriage, and as you type, the key stayed in one place and fired up, and then the carriage would move along. So I mean, you must be thinking, well, this is certainly quite inefficient. Why have two separate actions to move the carriage and feed the line? Well, the answer being, back then, if you wanted to write something in bold, you typed it out first, and then you did a carriage return, and then you typed out exactly the same thing again, as many times as you needed to make it look bolder. Also, if you wanted to do things like strike-throughs and other special characters and things like that, you would need to control how many lines exactly which line you were typing onto. So either way, and this isn't a talk about typewriters, but it definitely made sense to have control of both separately. So, Gary's operating system, CPM, which stands for Control Program for Microcomputers. It was being designed to be used for a terminal. Those monochromatic CRT displays they were all the rage back then. But the problem that Gary faced was this: what command should he send when he wanted a new line? Because Gary's CPM was also being used to control these teletype machines. So on an electronic display, he could send anything. He could just program anything into the OS, and that would be the command. Like, you could type the word banana, and then that means a new line. He could do whatever he liked. But the problem that you got with these teletype machines, and this one's moved on to a print head, like a modern day printer with a print head that moves along a track, is that you've got to tell it to move the print head back to position 0 and then roll the paper up slightly. At this time, some guys working on an operating system that would probably end up going nowhere, called Unix, well, they were just giving their terminals one command. They were just sending the line feed command, and that was it. But But Gary was a practical man. Gary believed in backwards compatibility. So he said, you know what? To denote the end of a line, I'm going to send a carriage return character, carriage return instruction, and a line feed character. Otherwise, I'm just going to scramble the output and it's really going to upset a bunch of people. So he did the only thing that made sense. 2 commands and, well, carriage return, line feed was effectively born in the programming sense, CRLF. And if you're interested, what CPM looked like, it kind of looked like this, and that's probably starting to look a little bit familiar to people that were messing around on early Windows systems back in the day, and it got bought by this guy a few years later, and then he would go on and build this company, which would buy out, they bought out CPM, and this company would use CPM and rebrand it the Disk Operating System, or DOS, which then became the bedrock of the next generation of operating systems that Microsoft produced. And it would ultimately mean that a generation of developers, and even us today, have to put up with things like this. Line endings. All because Gary wanted to be backwards compatible with a printing machine that ultimately became obsolete within a few years of it. So the next time that you're getting, this one was a good one. Next time that you're getting the line feed will be replaced by CRLF error, or the next time you're just staring at a terminal full of LF will be replaced by CRLF, or even anything to do with line ending compatibility. You've got Gary and CPM to thank. Thus, the end of the first story. So, my next story, and I'll pause for a wine break, to Alex. Also, this is a completely unique public speaking experience for me. Talking without hearing. I don't know if my gags are falling. It's like, it's like John's laughing. That's good. Are people typing things? Oh, do I have to respond to the chat as well? I can't see the chat as well as everything else. So if you are typing things for me, I am not ignoring you. I just can't show that at the same time. Anyway, sorry. I'll go on to my second story of the evening. And it begins some years before Gary would piss off every developer that came after him by choosing to use 2 characters for a line ending instead of 1. In fact, this next story starts in the 19th century, and it begins with a conversation about what bit of paper should we print money on. Now, I don't have the details of that conversation, but what I do know is that a decision was made, and the result of this decision would have deep ramifications and change how all of us thinks about programming and best practice when programming as well. This rather exquisite piece of craftsmanship. This is a 1980 United States Federal Reserve note, a $10 greenback. It is, dimensions-wise, 188.9 millimeters across, 79.8 millimeters in height. And just for kind of comparison, it's about 20% larger than the US banknotes in circulation today. the US Treasury were able to, when they decided what paper they should print money on, they were able to print 10 of these to a sheet. And more importantly, when money that had been printed was being transported around, they were transported in these secure, custom-made US Treasury boxes. And you can imagine if you're printing a currency, you're going to need a lot of boxes. Maybe a few of them were hanging around. Anyone know this guy? No? Okay, so this man is Herman Hollerith. And like most gentlemen of his age, he had an epic moustache. Herman had the misfortune of working in 1880. His job was working with the United States federal government, working on the state census. This was a laborious and an error-prone task, and one that Herman thought, well, look, we can do a lot better than this. Herman, like many people of his time, was a bit of a polymath genius, understated, and a true engineer. So Herman would spend the next 10 years working on an automated solution for the collection and processing of census data. And after almost a decade of diligent work, and he even went off and got a degree in engineering, and filed a patent, Herman Hollerith, he would change the world for good as he birthed this, the tabulating machine. I mean, this was a marvel of its time. And reminiscent of, I think you might be thinking of the Turing's machine, the Enigma. It was phenomenal. So punched cards were read on the main station. They were put, if you can see my cursor, they were put just in here, and the lever was pulled down, and it would read the data on the card. And then on the right, one of these kind of copper things would pop up, and they would put the card into that. So it had read the data, the census data from the card, and then this was basically an automatic card sorter. So you can imagine, like, this would have revolutionized how the speed with which they can take census data and the speed with which they can process it and sort it. So Herman, I like Herman. Herman was a true engineer, and he only solved the problems that needed solving. So he designed the cards. You know, he's working for the federal government. He's designed these cards to be compatible with the existing treasury boxes, these secure boxes that were used for transporting money. So the most simple thing was to make them the same dimensions as the dollar bills that would have been getting transported at the time. And Hollerith's tabulating machine, it was a phenomenal success. He would go on to found the tabulating machine company just 6 years later in 1896. And then through a series of mergers and acquisitions and buyouts, his company would become part of a consortium known as the Computing Tabulating Recording Company. Yes, these Americans are so good at naming things. And that company would go on and become massively, wildly successful. And in 1924, they would change direction slightly, but still be very much kind of I guess pro punch cards. So in 1924, they'd rename themselves again, and although they didn't get any better at naming things, looks like this time the name that they picked, it kind of stuck. So in 1924, the Computing Tabulating Recording Company would rename themselves International Business Machines, or IBM. So the card in this diagram, it's 24 columns and 12 rows in a lattice. And the holes that were punched in it were originally circular, so think like just a regular kind of hole punch. And for those of you who remember their their geometry classes, circles don't tessellate fantastically well. But the clever people at IBM, they came up with a doozy. How do we increase the capacity of this punch card? How do we do this? Square holes. Square holes is what they came up with. So behold the IBM punch card. And what you're looking at here is this is 900, potentially 960 bits of raw information right there in this beautiful blue manila thing. Later on, so this is 12 rows and 80 columns, which is quite interesting. And they'd later up this to 25 rows, and still keeping with the 80 columns. That seemed to be a bit of a winner. And that 80 by 25 would go on to hold 2,000 bits of information. This is incredible capacity for the time. And the format, this punch card format, would go on to become the industry standard for computer programming. So computers like the PDP-8, which would run you would program them using Fortran, and you would punch the programs into these cards and then load them into the machine, and the machine would read the program and execute it. And so punch cards like this have featured heavily in the space program. Even the computers that would be calculating trajectories that put man on the moon. And so ubiquitous were these cards that when the old CRT, when the old cathode ray tubes screens became a bit more commonplace as an interface, giving, rather than, like we saw earlier, typing things in, hoping you got it right, sending it to the mainframe, getting it back, printing it out, going, there's an error there. Getting that instant feedback from the computer via a screen. It meant that basically the thinking of the time was, well, why don't we make the screens hold as much information as a punch card? Which seems certainly like quite rational. It was a bit of a technological challenge at the time. 2,000 characters on a screen at once. Crazy resolution, 640 pixels across. But that became the kind of standard. Like, everyone was working towards making a screen that could display 80 by 25 characters. And this is an example of the deck VT100, which was a seminal terminal and copied by absolutely everyone, pretty much everywhere. But time moved on, technology improved, and storage improved. So you didn't have to carry around bundles of punch cards anymore. Programming languages changed. You could write the program straight into the terminal itself and save it to some kind of solid state memory. And as the resolutions increased, these 80 columns, you could fit 120 columns, 160. You could fit way more than 80 characters across. And so the 80 column limit became, well, not needed really, but everyone was so entrenched in it, in this thinking. All the programs that had been written hitherto had to stick to this 80 column limit, and so people kept enforcing it. And then some people decided that, 80 characters is quite an optimum length for reading, and all sorts of things like that. And so it stayed, this 80 column character limit. And so every time you see a line like this in your editor, or if you've ever wondered why that's in there, and every time that you run your linter and it tells you that, you're not following PEP 8 or PSR 1 or whatever, any of these standards, anytime you see that, just take a deep breath, be calm, hold your hand up to the sky and say, thank you, Herman Hollerith, and your fantastic tabulating machine. And that is the end of that one. So those are two stories that are, wholly unnecessary. They won't make you better programmers by any stretch of the imagination. But I think they're interesting. I did sociology at university, so I'm a bit of a kind of, I like the story of how things got there, and I'll show you this as well, something that I do in my spare time, which is making art out of computer pieces. So this is actually the first ever PC. I think this was one of the first PCs I built. So
literally, my drink mat is a hard drive platter.
Excellent. This bad boy here is an AMD K62-500. So that's...
It'll end up in landfill otherwise, rather than just sitting on the wall looking pleasant.
Yeah. Yeah, absolutely. And anyway, so I got a little bit of a bonus for everyone because I'm nearly at time, which was some things that I learned along the way that you might or might not know. So these are some fun facts that I learned along the way whilst kind of researching this. And the hard thing about I really wanted to kind of get a third story in there, but a lot of the stories of computing, as you might expect, like the history of computing, are just very kind of logical and rational. And you kind of follow them and you go, well, this seems like a series of very sensible decisions that were made and not interest at all. But I did find some, interesting things along the way that you might want to know. So the etc. folder in Unix-like systems literally means etc. And it was originally just a dumping ground for config files and things that had no other place in early Unix systems. So they just put it in a folder called etc. And that is it. So that's fun fact number one. Tilde is the home directory because it used to share the same key on early keyboards as the home key. And this is actually a bonus within a bonus, because we see in the top right here the very early keyboard. So this would have been one of the ones used at a terminal, like a PDP-8 terminal or something like that. And yeah, you've got the home key. It's got three things on there: caret, tilde, and home. So it became, home doesn't have a character; it's a command for the cursor. And so tilde then became the kind of character representing home in kind of Unix-like systems. And then the double bonus within this is the old, if there's any Vim users out there, master race, the old HJKL. This was the cursor line originally. So when VI or Vi, however you want to pronounce it, was created back in the day, it was still very much kind of transactional, dumb terminals you'd be typing into, and the response coming. So it'd still be very much like dumb terminal mainframe. You send it, the mainframe gives you the response, and if you needed to kind of sort of cursor around, you would use HJKL, and Vi was originally used for effectively composing commands to edit documents that actually lived remotely, and doing it with some kind of semblance. didn't have a mouse or anything like that. But yeah, HJKL used to be the cursor keys, so that was pretty cool. And look at this repeat key. That's interesting. I didn't notice that. And the old line feed here. Good old line feed. Oh yeah, this was quite interesting. If you read, there's a nice little thing about the history of HTML, yeah, marquee and blink tags were basically put into the specification. They were invented by Microsoft and Netscape respectively. So Microsoft decided, yeah, marquee is a cool thing. Blink, Netscape guys were like, yeah, this is awesome. The world needs this. But the thing is that nobody, like Microsoft didn't like the blink tag and Netscape didn't like the marquee tag. But they had representatives. They were like both part of the fledgling World Wide Web consortium, W3C. So, like, they're trying to ratify I think it was the HTML 1.0 spec, and they're really at loggerheads, and they strike a deal with each other because, like, no one else liked these tags. They're ridiculous tags. No one else liked them. It was just Microsoft and Netscape, and they struck a deal that Netscape would remove the blink tag from the spec if Microsoft removed the marquee tag, and so they did. But then what happened was that they went off and, like, HTML is an open standard, and so marquee was like, Microsoft were like, yeah, do you know what? We can just like put support for the marquee tag and then write it into Internet Explorer. And Netscape clearly had the same ideas about the blink tag. So in 1996, a new version of IE launches. That's Windows and Mac compatible, and lo and behold, the marquee tag is there. So yeah, that was another little fun fact there. But anyway, I've taken up enough of the time. Hope you guys learn stuff, and I hope you feel just like a little bit more elite now. That is it from me. Search for me on LinkedIn. You can email me, aaron@62.tech. And that's it.
Thank you. It's really strange people clapping on the phone.
Yeah.
So, any questions? Sorry, my computer just changed again. So yeah.
Sorry.
Sorry, the comments are amazing. Thank you, guys. Aaron, how did
someone worked with CPM? No way.
Yeah.
That's awesome.
Aaron, with the questions, do you want to get people to write it in the chat or just shout at you?
Oh, shout at me. Way better.
Okay. I'll be looking at the chat if people do want to.
I've got a question for you. You collect computer memorabilia. What's your favourite piece of computer antiquity that you've got?
It's not up here. One sec.
Completely derailed this, haven't you?
Sorry, I've got a box of
Sure,
somewhere.
We've got a box with loads of bits in it.
Somewhere I have, might be in here. Oh, well, there's two things. One is my, I've still got my Amiga A500 Plus, which I love, and it still works. But I also, bugger, that's not it. I also have somewhere in here. Nope. I've got an 80486 somewhere lying around, which I'm particularly proud of. But it's not in this bag. I literally like collect CPUs and stuff. I mean, these are all like Pentium Ds. got some. Got some AMDs mounted up here as well. Oh no, I think I mounted the 486. But yeah, between that and my I really want to get. Huh?
You collect Spark chips?
No. Like I'm kind of limited at the moment to stuff that I remember. But I do like when I have a little bit more space, when I make my millions, giving computer history lessons. I'll definitely, because I read this blog once about this boy that bought he bought like an old Cray supercomputer, like one of the Cray ones or something like that. It was mind blowing. But I'd really like to get properly into kind of collecting. Yeah, this is just like shit that's passed through my hands that I've kept for decades.
Swap shop in Code Harbour. Oh, I think that's probably my favourite part of this whole thing, is watching you just going through a box of stuff, going, oh, I've got CPUs. Oh, that's brilliant. Any more questions?
I've got another fact though, if you're interested in this one, Aaron. So
yeah.
You mentioned the punch card.
Yeah.
So in computing, when Babbage created his analytical machine, it was Ada Lovelace who, when she saw weavers weaving patterns and using a card with that pattern on, so the weaving machines could actually replicate the same pattern over and over again.
Yeah.
She thought that'd be a really good idea to put it to the analytical machine, or Babbage's analytical machine. So therefore, she actually invented the punch card for computing.
Oh wow, that's phenomenal.
And that's Lord, and she's actually Lord Byron's daughter, the famous poet.
Oh wow, that's awesome. That's really cool.
So another bit of fact there, and that's why we got the Ada programming language. That's where the Ada programming language comes from. It's her.
Oh, excellent. That's really cool. Nice.
I've got a fact that's related to you talked about the Super Cray computer.
Yeah.
I used to work with a guy that bought a huge computer from the States and had it shipped over. And he lived on a farm, and he installed the computer in his barn, and we actually went and had a go. I mean, it was punch cards. We actually ran a program on it, which was absolutely amazing.
Phenomenal.
But the barn, his parents owned the farm where they filmed The Darling Buds of May.
Oh right, okay.
So if you watched that, one of those barns had a huge computer in it.
Oh, phenomenal. Yeah, that's really cool, man. We were in where were we? God, I have no idea where we were, but we were in this museum of technology. No, it's the Engineering Museum in Paris, actually. That's really worth a look. There's so many geek points to be found there. And they had a whole just section on computing. They had a replica of one of Babbage's. It was because he had a couple, didn't he? He had the analytical machine and the I should know this, but it was I can't remember. Glenn, what was Babbage's other one?
Oh,
because he had the analytical machine and
the analytical machine is the one that I remember because of the story of Ada Lovelace. That was the story I followed. I was into a bit about females in computing because I always felt they'd been understated over the years. There's her, Grace Hopper is another one that was mine. Yeah, but no, I can't remember the name of the machine. Sorry.
Yeah, do you know Grace Hopper's thing was with the she had the stick, didn't she, for measuring the because you could measure like the response times. It was something to do with like the speed of light, and she had this stick which she used to she had this stick which she could use to measure like how well the computer was performing. by measuring out, or was it to measure like the lengths of cable to make sure that the instructions reached the point at the same time or something?
Someone's Googled it and they said they should put difference engine. Is that
Difference engine, yes, that's it.
okay?
That's it. Yes, excellent. Difference engine, that's the one.
Actually went to Grace Hopper's grave. Yeah, she's buried in Arlington Cemetery in Washington, DC.
Yeah.
And I was just wandering around, and someone said to me, "Oh, have you been to see Grace Hopper's grave?" And no, I'll go have a look though. So I was quite chuffed because she lived through her 90s. She was an old lady.
Yeah. She invented COBOL, didn't she?
That's it. Yeah.
Yeah. Which is phenomenal. Have you seen the film Hidden Figures?
Yeah.
Yeah, that's phenomenal, and that
was on recently. Yeah.
Yeah, they were all real women, and the one that was it Fortran that she was programming in, or was it
Fortran, I think.
Yeah. Yeah, that's actually one of my favorite movies. It's just a brilliant story.
What was this?
Hidden Figures.
Hidden Figures.
Yeah.
It was Katherine Johnson, wasn't it? She died. It was very, very recently.
Oh, really?
I think it might have been this year.
Yeah.
So I'm going to have to say, have we got any more questions? Because we probably should take a break.
Okay.
So I do actually have a question. I do have a question about the carriage return line feed. So what's the reason why we keep it in now then? If it's backward compatibility, is there no way to actually change that so that it is always a carriage return line feed? Why haven't there been more efforts to do something about that?
Well, there kind of have and there haven't been. I from what I understand, there's a bit of like back in the DOS days, that would have been huge, because there's if you think of an operating system almost like a especially modern day operating system, especially Unix like ones, like you've got the kernel, but then you've almost got this like bionome of like little programs that require each other to run. I suspect we could just have, like an end of line, a universally accepted end of line character, but I suspect so much shit would break in making that transition that it's just untenable. I mean, Microsoft, they kept on to like Windows 98. Windows, it wasn't until like 99 when they were like, okay, we're going to drop DOS with the advent of Windows 2000. And even then, like, even though that used the NT kernel, like, they still kept the same line endings, or the same passing of line endings at least, to be compatible with like all the other kind of DOS based things. So I kind of feel like it's just too fundamental to kind of realistically change. And it was only a couple of years ago that they finally wrote in support for the Unix line endings in Notepad. Like 33 years it took them to write that. It's just utterly ridiculous. But I literally think it's just like inertia and fear, and like we would all be happier if there was just one thing, and I just don't know if it's practical, to be honest.
So semicolon is not the solution.
Yeah, not at all.
Anyone else? Questions, comments, random facts? That's the thing we're doing now, I think.
Facts for the win.
Yeah, I've never done that before. I think we might just have to do that. Just get everyone. Right. So obviously we've overrun, but
sorry.
Like, it's not like we've got anywhere to be. So I'm going to probably put break for like another 10 minutes, just so everyone, you know, goes to the toilet, refills on the drinks, etc. So yeah, should we come back at past? Is that all right with you, Karen?
Yeah, we're good.
Karen? Yeah, your mic's off.
Yeah, I'm muted. Sorry. Yes, that's fine.
Cool. So we'll come back at past, and then yeah, we'll just go on to. Obviously, if you go past 9, it really doesn't matter.
Okay.
Cool. All right. So I'm gonna we'll start back up in a little bit. Thank you so much, Aaron. That was amazing. Thank
No
you.
worries. Thanks for having me back.
Thanks, Aaron. That was brilliant.
Hey, good job, man.
Yeah, thanks, Aaron.
Thanks. Cheers, guys.
Thank you. Right.
All right.